It's all part of the game. They have to make it look fantastic. They have to trigger your imagination.
If they've signed a contract for $1 billion or whatever it is, $4 billion to make the suits, they've got to be seen to do something. Whether they work or not is a completely different matter, completely different question. But they have to be seen to have produced them. I mean, how many suits are you going to get for $3 billion? I don't get it.
Yeah, well, that's the Axiom suits, and they haven't actually produced one yet.
No, they haven't.
And if those damn things worked, they don't need to spend $3.5 billion. By the way, that's just not to buy them. That's just to rent them once they get them made. That's a rental contract. And Collins couldn't do it. And the Latex Corporation couldn't do it.
Yeah, I was going to say, ILC, International Latex Corporation, and Dover, they did it 60 years ago for Apollo. We've seen those great racks of suits. That's what they produced. And we're told they worked. So as I said at the time, why don't you just take one of those suits, copy it, and maybe with a nice bit of design in it, get a few Hollywood costume designers involved so they make it look pretty. And everybody can say, oh, that's a lovely suit. Just copy the Apollo suits. They worked.
Well, there's complete detail on every layer in the Apollo suits.
Yeah. Was it 20 layers they're supposed to have had?
Well, they had 11, then they had 14, and then 21.
Yeah. But not one of them protected against radiation, did it?
No, they got x-rays to show just how well they protect from radiation.
If you can x-ray those suits, which you can, and you can see right through them, what are x-rays in space going to do? It's going to go right through them, and it's going to hit the humans inside, us delicate little creatures who don't like too many x-rays.
Yeah, and right through the film, too.
Oh,
we're always coming back to the film.
That's the point. When you take an x-ray, you go and have your tooth x-rayed or your head x-rayed or whatever it is, the x-ray exposes the film in the carrier that you have inside. Well, it's maybe digital now, but that's what used to happen. And guess what? The technician setting it all up for you to get your tooth x-rayed wore a lead apron to protect him. The room in which it's designed, the room in which the x-ray machine for a dentist is designed, has to have lead shielding throughout the whole room. That's why they're so expensive. I mean, when you go and have your tooth x-ray, you don't see the lead shielding. You see the technician wearing his lead apron. So what do x-rays do? They go through stuff. That's the whole point of x-rays.
Yeah, and the funny thing is people don't understand that it's all radiation. Light is radiation. And to give the best example, just put your hand over top of a high-intensity light and you can see through your hand, just like an x-ray. You get enough bright white light, you can see right through your hand.
Of course you can. Of course film is affected by radiation. That's the whole point of it. That's what film is designed to do, to be affected by radiation. That's why you take a photograph and it records it on the negative of the film. And if you haven't seen it, haven't used photographic film, I would keep showing it because people don't know what it is. If you don't use photographic film, you won't know what a negative is, how you produce a print from it. And that's ester based, polyester based, that's plastic.
But I'm sick and tired of this film where these guys are saying it's magic film. It's this film that works in space. But the thing is that David Percy went to these scientists and asked them, and they said that it's just thinner. The base material's thinner, the ester base, the plastic, whatever you want to call it, it's thinner. Yeah. And they used a finer grain. But that's it. There's no special coatings on this. Yesterday, we had this one guy in the comment section. Oh, well, they used ultraviolet protection on the film for the LRO back in the 1960s. But when Scott looked it up and they didn't have it till 1981.
1981 was the first UV protection. But that still has nothing to do with the type of radiation that would damage the film. UV coating wouldn't touch it.
It's interesting that they talk about finer grain on the film. Now, a finer grain film implies that it records very good detail, but the film is a slow speed film. You get high speed film, say 400 ASA, American Standards Associated, whatever it is, or ISO, International Standards Organization. 400 ISO would be a fast film for low light conditions. we're told that the moon is quite bright. So it's logical that they would use a slow speed film. Makes sense.
Explain it further, because we're talking milliseconds of exposure time.
Yes. On the Hasselblad camera, you can set it to expose at an extended period, so 20 seconds, 30 seconds, you can do that. And then you come down to 1 second, half a second, quarter second, fifth of a second, a hundredth of a second, a 250th of a second, a 500th of a second. Now that's quite a fast shutter speed. So you need to have a high resolution, fast film to record that information, because there's less light coming in through the camera. If your aperture is closed down, say to f16, f22, that's letting less light into the film. Therefore, you need a faster film to record it. The two work in tandem. The faster the film, the shorter the exposure can be. The slower the film, with fine grain, recording in much more detail, requires a much more open aperture, f5, 6, f8, f11, maybe up to f16 if the light is fast. Those two work in tandem. So to say that you have fine-grained film implies it's a slow film in terms of requiring more light to be let in to record on the film. It's not rocket science, it's basic optics.
I'm just looking here in the cue cards on Apollo 12, 125th, the camera settings in the cue cards were 125th on here, and some of the other ones is 250.
Yeah, a camera speed of 125th of a second, the shutter speed, is relatively fast, and that means you can hand hold it. It doesn't record the movement. If you go down to a quarter of a second, you've got to have it on a tripod or you get camera shake.
So then why in Apollo 17, when they were taking photographs with that telephoto lens, you could see it. The astronaut has that Hasselblad camera with that 500 millimeter lens, and he's click, 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 and he's taking pictures of far away distances. How can we not get shaking in there? How can he even get a picture without a tripod?
Of course you must have a tripod. A 500 mm lens weighs about 2 kilos.
But remember, that was the 500 millimeter lens on the Massif, on the South Massif or the North Massif. You see where he was when I'm showing that film. He's standing right beside the LEM.
Yes, he is.
He's taking photographs of a mountain that's miles away.
Yeah, and there's no camera shake on it.
Nothing.
That makes no sense.
Let's say he had it on 1/1000th of a second.
Well, it's possible that he could have got it without camera shake, but it would be a bit of a risk. And there he was on the moon, a unique location. You'd think he'd have at least rested it on a nearby rock, which is what you can do to keep a camera still. But he had it up here. He was up, what was he doing? Looking through the viewfinder? It makes no sense. I mean, it was just showing him using the 500 millimeter lens on the moon.
Once again, they're showing you an image to trigger your imagination.
Yeah. And you think, oh, look, he's using a 500 millimeter lens. And then they put a picture up, which he could have taken, but in the location he's supposed to be in. And this is what he took. Yeah. I mean, that thing I show when I do my presentation, I think it's Tracy's Rock. And the lunar lander is in that picture, but you've got to zoom in so close to find it. And it's a tiny little object. It's about 3 miles away from the camera. Now, you try taking a photograph, even with a 500 millimeter lens, of an object 3 miles away from your camera position, and just see how much information you get. Very little. I mean, 3 miles is quite a distance.
Yeah, well, that's probably 2,000 feet across the set.
What about those pictures, though? I wonder where they are, or where can you get them?
The only place I've ever found them is on the Lunar and Planetary Institute website, which has all the magazines taken on each mission, and they show every single photograph. So if you go into Apollo 17 magazine, there are quite a few on Apollo 17. They were very busy taking photographs, but they got lots and lots of pictures there, and you can go through them. You can see what they were doing and how they were taking the photographs. Because basically you're looking at the contact sheet of the magazine.
If you're on March to the Moon, they show you the camera and the lens under each one.
Actually, in Apollo 17, really, they're using 80 millimeter and 250 millimeter, all the magazines from 139 to 155.
Is the 500 millimeter lens not shown there?
So this is magazine 144. So it was the Zeiss 500 millimeter with the f8 setting.
Because Zeiss made those lenses specifically for the Hasselblad camera. They don't fit on any other camera.
Oh, and they were using aerial film for this.
Yeah, that makes sense. Because that's, I said last night, Victor Hasselblad originally designed his cameras for use by the Swedish Air Force in World War II for aerial photography. So the camera would always be physically mounted into the aircraft. They wouldn't be handheld. What's in that picture, Scott?
Just a picture of the hillside.
Okay.
Is the next photograph 500 millimeter?
That whole magazine is
Magazine 144?
144, yeah.
Oh, here we go. What are the dates on there?
And the date on this was
29th of November. That's before they took
This
off.
is
what? Before they took off.
Well, didn't they take off early in December?
What? That's a month before they.
a
No.
couple, like everything's a couple. That's November 29th.
Yeah, November 29. What were they supposed to be doing on November 29?
Filming the simulation.
Oh, of course it was. Yeah, sorry, I forgot that.
Okay, so everything in magazine 144 are 500 mil.
Yeah, all of them.
I'm just going to scroll through some of the shots here of the 500 mil.
Magazine 139 is as well, and it's the same. It's all the hill.
It's not showing very much of interest.
Well, for a 500 millimeter lens, it's just blurry shit, isn't it?
Yeah.
Oh.
The 500 millimeter lens has an angle of view of 4 degrees. The 60 millimeter lens has an angle of view of 45 degrees, which takes in far more. That's why it's a wide angle lens. This is the telephoto lens.
Well, how far back from a mountain would you have to get to catch that much of it with 4 degrees? So they claim that they're like miles away.
You see magazine 139. Oh my God. There's nothing here that makes any sense. It's every one of these are blurred to bits.
Here's the start of 139.
They're all the same. There's no ability to work out whether that's about 20 foot high or 2 foot high.
Well, I'll tell you, that's pretty unusual stick. I'm at 21990 right here. Looking at this stick laying over here with the knot in it over top of that rock.
No way of telling what size that rock is.
No. And you don't know how level it is. They could have just tilted the camera. Pretty round right in there. Man, when you get an impact crater and you get objects like this showing up, like, look at that. I mean, it's got a knot right there. This looks like a broken branch. Perfectly round that is in there. Like, the rocks just are not rocks.
I was going to say all the shadows are very black, aren't they? Where you've got the sun shining from the right, and the shadows are on the left, and they're all black.
Yeah, well, they're supposed to be, aren't they?
But when astronauts come out of their lander, they're lit up like a Christmas tree. Makes no sense.
Well, even here up close, you can't see anything in the shadow.
No, nothing at all.
They're just using camera effects.
That looks like the lander in the center there.
It is.
It is.
It is. Yeah. Is this 500 mil?
Yeah, that's 500 mil.
See, now here's a comparison.
That's weird. That's on a slope, and it's with the sun on the left-hand side.
The sun shadow is almost the same direction between this photograph and this photograph. Here's the sequence here I'm going to show. That kind of matches this photograph.
You even got the slightly lightened surface coloring.
And I'm looking at just the sun angle here, fairly close.
The sun angle's the same.
This shot would have been taken over here somewhere. It would have to be down here, this photograph here. Well, they never traveled anywhere out here. There are no tracks anywhere. They would have to come in from here.
I wonder if the tracks would actually show up at that distance.
See, and it's still right there.
Yeah, it is. It's right there. It's
Okay.
tiny. I mean, that shows how far away it is. And that's why they took that picture. So they would have Tracy's Rock in the foreground and the lander in the background. But it's so far away, unless you know it's there, you wouldn't be able to spot it. You'd think it was just a rock.
Yeah, but when they were traveling here, they were coming in from the left side of this photograph is where they were traveling with the rover.
Okay. So where are the tracks there?
The tracks don't go out to here.
No.
Oh, there's that beautiful hole in the wall. This particular photo right here with the hole in the wall is magazine 140, 21 $495.
And what's that weird looking thing in the foreground?
That's one of the Apollo 17 experiments, and it's got solar panels on the top of it. That's the lander in that one right there, just that little spot right there.
That's right. Yep, it is.
My whole thing is when we're looking at this magazine, the ground is very, very level against the mountain, and the other one, it's on an angle against the mountain. Never mind just that you could be up on a hill or whatever shooting down at it. Everything is coming on an angle down from the mountain. I got the two up here. I'll display it again because I don't know how you could do this. There's the two photographs side by side. So you take those two images. This is level. I'm talking about this line across here at the base of this mountain in comparison to how level this thing is sitting compared to this and this slope. See how level this is? It doesn't match this.
No, it doesn't.
This is a completely different terrain. It coming down here. And if that's supposed to be there, where is this big rocky crater?
Don't forget that's from a different sun angle as well.
The sun tilts the earth like that.
The right-hand picture, you've got the shadow on the lander, on the right-hand side of the lander.
Actually, that shadow is headed that way out.
Yeah, it is. Yeah. Because something that they didn't really tell us very much about is that every Apollo mission carried nuclear reactors on board to produce the power.
Apollo 11 did not have one.
The only thing that didn't require any power was the reflectors, because they were reflecting light. The seismograph required power to transmit the information, allegedly.
There's not one hanging on the side of the machine. Apollo 12, the 17 had this RTG.
Which is a bigger one.
You see, it says that the RTGs were used to power the two Viking landers and for the scientific experiments left on the moon by the crew of Apollo 12 through 17, SNAP-27s.
Right, but this is the one that they open up here, and it runs on solar panels. And all the experiments are in there. That's not an RTG in there. That's the experiments in there. That's the antenna. And they only had a few experiments in there, and they were running off these solar panels. Then when you get to Apollo 12, it's in this thing.
It's interesting, in the press pack, all 250 pages of it, there is no mention at all of the Van Allen belts. There are no diagrams illustrating them. There is no mention of them. On the second orbit, after the launch of Apollo 11, it fired the translunar injection engines over the Pacific, just south of the equator. So they didn't do a polar exit. Well, they couldn't. We know they didn't. Bart was trying to get some detailed information about what was said about the TLI departure. Where was it fired from and where did it go? If it's fired over the Pacific, it's going straight through the belts, assuming it got that far.
Well, when they launched, they went across the eye in Africa.
Yeah, the eye of Africa.
Well, that's their orbital path right there.
Yeah, it was launched on an orbital path, not a polar path.
They should have come off, 5 degrees north of the equator, about 5 degrees up when they did the translunar injection, because that's where the moon was.
Exactly.
You have to be in that path.
Basically, you're launching where the moon will be in 3 days' time, because you've got to intercept the lunar orbit. You go straight to the Van Allen belts, but they're not mentioned. Not in the press pack, which was published on July 6th, 1969, so it's 10 days before they launched. They published the press pack, and they say very clearly where they launched, basically near Hawaii, just west of Hawaii.
You see, this is what it says here. Apollo 11 astronauts Neil Armstrong and Buzz Aldrin set up the first series of nuclear surface experiment packages. The experiments were powered by a radio telescope thermoelectric generator, RTGs. The experiments flew with the crews of Apollo 11 through 17 and operated until 1977, far longer than expected. Well, what are they talking about when they're talking about the RTGs? We're talking about...
So that said the RTG was in 11?
Yes.
I think they're only used on the seismograph.
That's the only experiment they stick out on the ground there.
You'll find the description of the start of TLI on page 30, where they describe it. Quite a short paragraph, but they describe it quite clearly. And there's also an illustration of where the 3 ships stationed in the Western Pacific, west of Hawaii, north of New Guinea, which were to receive the signals. Now, I would suspect those ships were there in case there was a problem with TLI. because there's also another ship in the North Atlantic under the flight path. They had 4 ships out there on the launch of Apollo 11. And those signals were then transmitted up to 2 satellites, presumably in geosynchronous orbit, which could then transmit them back down to Houston and various other stations. So they had 360 degrees of receipt. They could receive signals from anywhere on the planet, because they had 3 major receiving stations on the land, Madrid, California, and Australia. And they had the 4 ships out there in the Atlantic and in the Pacific. So if they couldn't receive signals at the ground stations, they could receive them on ships. And they also had 8 aircraft flying, converted Boeing 707s to receive the signals as well, and then retransmit them up to the satellite. So it was a well-covered area. This is Apollo 11. I don't know if they had the same ones of the later Apollo missions, but 4 ships, what are they called? Mercury, Redstone. They're basically named after Apollo components.
Yeah, I don't see anything for an RTG here in the experimental package of Apollo 11. The solar panels operated the seismic experiment. You take a look at all sides of the Apollo 11 LEM, it did not have the little nuclear power source there.
Yeah, it only says passive seismic experiment package, but right beside it, isotope heater. That's all that's there.
That's it. You see the RTG in all the other shots. It's a big aluminum finned thing with little wires down it, and then he puts the core in. Like he takes it off the side of the machine and puts it in. That's in 12 to 17. Apollo 11 didn't have one of those. They change stuff all the time now. I mean, they got rechargeable batteries. Well, zinc acid batteries are not rechargeable. Sorry.
Oh dear.
Like in mid 80s or something, they experimented with them. The one reason they used zinc instead of lead acid is because it has holds a much larger charge, so about 30% more charge, but it's non-rechargeable. Buy little AA's or whatever, you buy a rechargeable one, it doesn't last as long as the other one lasts a hell of a lot longer that's non-rechargeable. That's the same effect that you're using with these bigger batteries they were using. The non-rechargeable ones would last a lot longer. And the thing that gets me is that with these things weigh 60 kilos a piece when they landed, and they used them up, why wouldn't they dump them out the door instead of the cameras? As they're trying to reduce weight. Like they got 3 batteries that weigh 60 kilos apiece. Dump those off. Remember they counted every stitch for weight?
Yeah.
Yeah. Well, if you took one of those batteries, even one of the batteries out there that's 60 kilos, you could put an extra 60 kilos of moon rocks, and you could have 2 or 3 of them instead.
And they only brought back 23 kilos of moon rock.
Yeah, but a 60 kilo battery, you could put 60 kilos of rocks on.
Yeah, they could have chucked one out of the lander. It was registered on the seismograph, and they could have calibrated it from that. We've done it 60 kilos, dropping 10 feet, produced that amount of vibration. That would be a much better experiment. But no,
Exactly.
they left the cameras there, for God's sake. I mean, those cameras would be worth a fortune now, assuming they got the moon, because they probably got little pits in them.
They'd be worth at least as much as Buzz Aldrin's signature.
Exactly. I don't know, Buzz Aldrin could sign it quite fast. I saw him doing it. $275 a hit.
Yeah.
Fast he could. About 60 an hour he was getting. I mean, good pension there if you can get it.
Yeah, but that was at one of those $1,000 a plate dinners, wasn't it?
Yeah, it was.
Yeah, and then you just pay that much more for his signature.
In the future, some people are going to get a little bit pissed off at the fact that they have been conned because he wasn't there. They might demand his money back. They better hurry up because he's 93 now, just got married again.
Yeah, he's 93 or 4.
Yeah.
He's done quite well for himself, considering.
He has done very well. Yeah, there aren't many moonwalkers still alive, are there?
Like when you start out as a pilot and you're a pretty good pilot, you think you'd want to keep that in your career. But, you know, like, because any pilots that I know that, you know, even if they flew commercially, they owned and operated their own private plane, and they fought tooth and nail to keep certified.
Well, it's, you know, for the standard limits for privileges for pilots and single pilot commercial air transport, 60 years, but they'll extend it to 65 for a multi-pilot operation. So I guess they're getting desperate.
Yeah. Yeah. Used to be like 55.
At the end of the press pack, in the index at the beginning, it says there's a list of subcontractors. and it's not in my copy.
Hasselblad's not listed in that manufacturer. They hired Hasselblad to design that. They hired Kodak to make the film extra thin, so it'd be even more volatile to radiation, half as thick.
And the Mara film cameras, Westinghouse.
Was Zeiss that made the lenses, or was that just part of Hasselblad?
No, Zeiss would make the lenses. They actually made a special one.
They'd be contracted to make a special lens.
And then you got the batteries, Varta, who made the batteries. That's a German company. Zeiss at the time was in East Germany because it was divided at that East and West Germany. Zeiss was in East Germany.
Now, there had to be a company that made the solar panels. I've never seen it listed anywhere.
No. So that's not a very complete list, is it? 7 or 8 companies involved. So that answers the question about 400,000 people who couldn't keep a secret rather well, I think.
Yeah, I don't know where people get that from.
No.
Well, here you're back to the politics when it comes to that. The U.S. government putting into an infrastructure into the U.S. economy, and basically they put 400,000 people to work. That was the input. That's the financial input. They were so slow in recovering from the Second World War. Everybody else was way past them. Look at Japan. I mean, you knock them flat and they jump up and they're selling new Hondas. All of a sudden, everybody's got a little dirt bike and motorbike. I mean, pocket radios and all kinds of little electronic stuff. The U.S. wasn't even close to that. Okay, as far as an economic structure, they had to put into the economy to give it a boost. But when they did this, those were upper middle income jobs that they were giving a boost to. That wasn't minimum wage jobs. So these people could buy houses, they could buy new cars, they could go out for dinner. It just bloomed off of that. That strengthened their economy and unified the nation. And it was falling apart during that entire process. And people were assassinated, you and that. They had to make these things land on the moon, or appear to.
So if your total budget was $25 billion and there were 400,000 people employed, the average salary would have been $62,000. So quite a reasonable salary.
You have to pay for the materials as well.
No, you're paying people to make the materials, paying people to dig them out of the ground.
But if they were making $10 an hour in 1962, they had an upper middle income.
That was good money.
$10 an hour in 62, you could buy your wife a diamond that would take her breath away.
Yeah. I mean, that would be, what, $20,000 a year?
Well, that's when they came out with that 3-month salary, when they knew these people were making that kind of money. $10 an hour was a huge deal. You realize in 1969, minimum wage in Canada was 75 cents an hour?
A lot of people are becoming aware of the depth of the research. That's the important thing. I mean, 30 years of work on it probably met most of the people who are aware of what's going on, or at least spoken to them. I mean, Jara's done some great work. Raza's doing pretty good work. David Percy, Mary Bennett, they do great work. And it all started because David Percy's father-in-law said, check the Apollo record. That's all he said. That's what set David off on his round-the-world trip to interview about the Apollo record. And the result of that was his book, Dark Moon, and the video.
Well, that's the whole point. We're basic humans. We work on basic biological principles. And the one basic thing that nobody can take away is that ability to trigger our imaginations.
Well, the imagination's going to get Musk to Mars.
Well, it's because it's endless. There are no limits. There are no limits to the imagination.
Hey, listen, eventually it'll get men to the moon, and women.
Definitely, definitely. Women are important to get to the moon. Otherwise they feel left out. They haven't got men there yet, so come on, guys, catch up a bit. Oh dear, oh dear. Hollywood at its finest, all that. It's great stuff.
The problem is you don't know what's real anymore. You see, this is the problem with that spacewalk, is that you're thinking there, you're going, wow, this looks nothing like Ed White's walk, does it? And why would they do it with a huge Earth in the background, which, of course, they're using a fisheye lens again. So, of course, you're going to get the edge of the Earth. It's going to look massive, but that, for all you know, that could be Africa, just the continent of Africa underneath you. And all you're seeing is the edge of it. That's it. So you don't really know what you're seeing. And that's the problem. But at least you should see stars, especially when they went into the umbra of the Earth. Now the automatic setting is the aperture is going to open up. You're going to see all these faint little points of light. Then we don't see anything. I have gone through that with a fine-tooth comb. I can't see a tiniest little flicker of light anywhere.